Just a second. No? Hi Aisha, how are you?
Yeah, ma'am,
Hi
I'm fine.
Sumit. Just a second. I am starting. Okay. So let's do the next few questions which are left. And yeah, today we'll be done with this trigonometry. So the next question which we can take over here is, suppose we are having 1 plus sine A over 1 minus sine A. Okay. Is equals to, we have to show that it is equals to sec A plus tan A. What can be done over here? Anyone? Again, yeah, the what will be the instruction? That instruction will be prove that left hand side is equals to right hand side. Okay, how will be showing it? Any idea? Yes. What to do over here? Abdul, Afnan, Aisha, Zunad. What can be done? Like whatever you are thinking about, please let me know. Are we going to take the left side or we are going to take the right side? Is like the rationalization will work over here or not? Like everything will be thinking about. Okay.
I think so, right hand side.
Okay, you want to take right hand side? Let's take right hand side. If we will be converting it in terms of sine and cos, so sec will be 1 by, just roughly we are checking it. This is 1 by cos and this is sine by cos, right? Right, Aisha?
Yes.
Then what to do?
Then we can take
Then we can take LCM, that is cos A, and in numerators part we'll be having 1 plus sine A, right?
yes.
Okay. So numerator, it seems like we will be able to prove from here. Okay, for now it seems like that, but there is a square root. Okay, there is a square root. So how can we bring a square root over here? That is the main confusion, right?
Yeah.
Anyone having any idea what to do over here? What to do? If instead of this cos A, if instead of this cos A, cos square will be there, then we could have written for cos square. See, I'm not saying it is cos square. Okay, just the possibility. If cos square, if it would be cos square, then how great. We could have written this cos square as a 1 minus sine square. Okay, and then we could have written this 1 minus sine square as a 1 plus sine and 1 minus sine, which we have done in like few questions, right? Right.
Yes.
Okay,
Yes.
but here since cos square is not there, we are not able to move ahead. And even if we will be able to make it like that, will it help us? So no. 1 plus sine in the numerator, we don't want to cancel that. Okay, we don't want to cancel it for now. So it seems like for now we are not able to proceed from here. What about if we will take the left hand side? If we will take the left hand side, is it possible to proceed? Is it possible? Only one thing which can come in your mind. In your mind also, is it coming? Rationalization. Is it coming?
Ma'am,
Okay.
but how to remove the root?
Inside the root only we will be doing. Since we are multiplying with the exactly same term, that means we are not doing anything. With one we are doing the multiplication. Okay. Inside the root only we are introducing this rationalization thing. And we are just checking. Okay. Let's check it. If we are having this, if we will be having 1 minus sign. Okay, 1 minus sign is there. No, it will be multiplying with 1 plus sin A by 1 plus sin A. What are we going to have? It seems like we'll be able to prove. See, it seems like we'll be able to prove. Check it. Randomly just we are doing here and there, and just we have tried rationalization, and we can see here we are having 1 plus sin A whole square in the numerator, and in the denominator 1 minus sin square A we are having in the denominator, that too inside the root we are having. Yes or no?
Yes.
Are you able to see that we are already getting this right hand side which Aisa has done? Can
Yeah.
you see?
Yeah.
Okay. So we are able to do proof left hand side is equals to right hand side. This is how you have to approach any question. Please don't memorize that this is how only we will proceed and this is the only way to prove it. You will create how to prove it, but for that enough practice is required. Okay, from here the numerator will be just 1 plus sin A and the denominator will be cos square A, but since it is inside the root, if you will take it out it will be just cos A. So this type of question also we have done, where we have to work on the left hand side also, we have to work on the right hand side also, and then we are able to prove that both sides result are same, hence left hand side and right hand side is equal. Okay, any confusion to anyone?
No.
Okay, we can say here LHS is equals to RHS. Let's continue.
Ma'am, what are these types of question used for?
What are?
These types of question like proving LHS and RHS used for? Like in trigonometry, the first two exercises were like used to measure the height and distance, whatever. But what about this one? Proving. Oh, why are we using this?
Why are we proving it?
Yeah.
Okay, what is the use of it? Why are we proving it? So actually when we are learning science, we say that the basic thing which we say that we will not if anyone will come randomly and will say this is the rule, okay, or this is the formula, or if anyone will say all of sudden that under root 1 plus sin A by 1 plus 1 minus sin A is sec A plus tan A. If anyone will randomly say, then we will say that how? Prove that. And
Yeah.
that's what we are learning here, that how to prove anything. In physics also, when you will be learning physics in higher grade in class 11 and 12 also, then you will be finding that there is a rule. Okay, there is a formula, a rule or whatever, and we will be doing the deduction, like we will be proving it with the help of the concept of sometime mathematics also. and we will try proving it how exactly, like from where exactly it came, how mathematicians or scientists got it. So this is how,
yes,
this is one of the way of getting it. And this, like this under root 1 plus sine a by 1 minus sine a is sec a plus tan a. How? So this is one of the way of finding it, and that's what we are doing. Why we are doing so? What is the use of these things in future? If we will sharpen our mind by doing this type of so many proofs and everything, then in future we will be able to think about like something which is very tricky, very like there also we are having sec,
yes,
tan, sine, cos. Quick we'll be changing, and we'll be maybe sometime we are having only like a sine angle, the sine of any angle in hand, and we need the sec, we need the tan, then we can convert it, we can find it quickly. These are the things which will make our mind sharp. So at least till class 10, whatever we are learning, these all the things are so much important in our real life also. In higher grade, when you will be doing the study of mathematics, core mathematics, then you will be just profession or wise also, you will be choosing such profession only. There it will help, of course these basics will help you, these basics will guide you. But till class 10, overall in all the subject, whatever you are learning, it is applicable everywhere in your real life.
yes,
Okay, if you will try thinking about other subject, then you will be able to relate also, that yeah, in biology, in chemistry, physics, whatever you are learning, yes, that's what you are seeing all around uh, yourself in your real life, and you need to understand, right? That is the difference between a person who is educated and the person who has not gone to a school. That will create the difference. We will understand things in a better way, right?
yes.
Okay, so yeah, let's continue. However, this is just the beginning of trigonometry, Aisha. When you will move in, when you will be taking in class 11 also, when you will be taking mathematics, this trigonometry will take a huge concept will be there. Sine and cos, which is so basic for now, you don't know anything about it. Just directly we have given you the formula, and directly we are saying that tan means sine by cos. There you will be seeing the huge application of that. Even if the roller coaster, when you will just when you are taking a ride of roller coaster, there also angles, there also each and every angles, here angles, here angles, it is designed in such a way that trigonometry help us over there also. The calculus, okay, it is also related to the concept of calculus. And there, here, for the construction of these things, we calculus is applied. Do you know that? And yeah,
Trigonometry I
trigonometry
knew, but
also.
calculus I did not know.
Yeah, trigonometry also, calculus also for the construction of buildings. Okay, architecture, who are studying architect, they learn that these are the basic. They apply it in real life scenario. Okay.
Okay. That is class 11, 10, 12 math very difficult.
No, it's not that difficult. Okay, if you will understand the concept, Aisha, if you will understand everything properly from the very beginning, yeah, you will feel that after class 10, like a quick, like you have to jump concept wise. But if you will try understanding the concept, okay, patiently, then it is not at all tough. There we are having the graph of sine theta. There we are having the graph of cos theta. There we will be learning about the graph. Okay. And yeah,
Yes.
calculus is also. So let's prove it, the next part. These are the puzzles which we are solving now. These puzzles is making our minds sharp. It will help us in future to take any problem and to solve it quick. Okay. Even if we don't have any idea
Yes.
what to do, we can start and we can keep on moving and maybe we will end up getting the result. Now the next question which we can discuss over here is sine theta minus 2 sine cube theta over 2 cos cube theta minus cos theta that we have to prove is equals to tan theta. Now think about it. Let me know what can be the possible approach for this one.
Can we convert tan theta to sine theta by cos theta?
Just a second only. Yeah. If we will convert tan as a sine and cos, after that we are not able to do anything, right?
Yes.
What about the left hand side? Can we do anything? If we will take out common something from the numerator and the something from the denominator, whatever is possible, what can be done?
We can take sine and cos as common.
If we will take sine common from the numerator, what will be remaining?
1 minus sine cube theta.
Sine cube theta,
Sine square theta.
sine square theta, 2 sine square theta. Is it so? Is it so?
Yes.
And here cos cube minus cos, what will be remaining?
2 cos square theta minus 2.
Perfect. Now sine by cos is okay. If any way we will be able to cancel out this one and this one, then we are done. Then we are done. But how to cancel that only we don't know, right? Right? If suppose here identity only 3 formulas we are having in hand, anyway if we will be able to write in this 2 sine square theta is there, no, this 2 is not, like instead of this 2 just sine 1 minus sine square theta will be there, then we could have written cos square theta. Yes or no? Yes or no? Are you getting my point? If 2 is not there, then we could have used the formula, right?
Yeah. Yes.
Okay. Since 2 is there, then how to use the formula? That is the main concern. Then let's write it. Let's arrange it. We just need this 2 sine square theta is not needed. We just need sine square theta. That means 1 sine square theta. So let's just break it by taking sine square and then sine square added together. Okay. So can we write it like this? 1 minus sine square theta. And then there is one more sine square theta. Can we write it like this? Minus 2 sine square theta. Can we write it as a minus sine square theta minus sine square theta? Yes or no?
Yes.
Can we? Yes.
Also, like if you're not taking a 2, then we can write
2x can be written as minus 2x can be written as minus x, right? Yes or no?
Yeah.
Similarly, minus 2 sine square theta can be written as minus sine square theta, right? Similarly, this 2 cos square theta minus 1, it can be written as cos square theta. Okay, let's keep it for now as it is. Or, okay, let's change it. Cos square theta minus, not minus, plus cos square theta minus 1. Any confusion so far? Any confusion?
So,
No. Now can you see 1 minus sine square theta is cos square theta, right? Minus sine square theta. Okay, in denominator, this sine theta is still there. In denominator, cos theta. And here also we want to use the identity, but we are having cos square theta minus 1. If it would be 1 minus cos square theta, then we could have applied the formula. So what we will make it, I was explaining you, if a minus b is there and if you want b minus a, then you can take out minus common. Yes or no? Yes or no? Can we take out minus common from this two part and it will be 1 minus cos square theta? Yes or no? Can we take out minus common? See, that day I was explaining you, if you are having a minus b, you can make it b minus a. How? By writing one negative sign in front, it will be minus a plus b. That means it will be minus sign in front, b minus a. Yes or no?
Yes.
Okay. So we can make it 1 minus cos square theta. Why we are so interested with 1 minus cos square? So that we can use the identity because we don't know where to go. Okay. So here we'll be using here we'll be taking minus common and hence it will become 1 minus cos square theta. And this, can you see now we were trying to make both the brackets same and it seems like we are done. Can you see? Can you see?
continue little bit.
See, sine theta by cos theta. In numerator, we are having cos square theta minus sine square theta. And in denominator, we are having cos square theta. And 1 minus cos square means sine square theta. Let me explain from the very beginning. At first, we do left hand side I am explaining. At first, we don't know what to do. But sine here, sine there, cos here, cos there, it looks like common factor can be taken. We have taken the common factor. After that, we don't know what to do. 1 minus 2 sine square theta was there. So we were thinking if 1 minus sine square theta will be there, then we will be able to apply the formula at least. After that, what we'll be getting, we don't know, but at least we will be able to apply the formula, which 3 formula only we are having in hand. And from that, the first formula we can apply over here if 1 minus sine square theta will be there. Why? See, the identity is sine square theta plus cos square theta is equals to 1. And from this identity, we are getting that 1 minus cos square theta is equals to sine square theta. And from this identity only, we are getting that cos square theta is nothing but 1 minus sine square theta. Okay, so this formula we are having in hand already. Okay, we are trying to use it over here. 1 minus 2 sine square is there. We are trying to create it 1 minus sine square. We did so. In the denominator also 2 cos square is there. So we have written cos square plus cos square. Okay, in numerator we found that now we can use the formula 1 minus sine square is cos square. Okay, This is what we have applied the formula in the numerators part, and in the denominators part, after breaking this 2 cos square, still we are not able to use the formula. Then we know how to make a minus b, how to make, like, from a minus b, how to go to b minus a. We know that how to do so. We have taken negative common and we made this 1 minus cos square theta, and hence we ended up getting same term in the numerator and denominator, and hence sin theta by cos theta came only, which can be written as tan theta. Or if you have already written the other side as a sin by cos, then you can say now we are done. Now we got left hand side and right hand side are exactly same. Getting it?
Yes.
This is just one of the way. If you will start doing it, solving it by yourself, then you will discover one more way. Let me tell you. This is just one of the way of proving it. There are so many ways. And if you will try thinking, then maybe you will be able to prove the same by you. Maybe another, by using the another method, you will be able to prove it. Okay. Any confusion so far?
No.
Okay. Just a second. Yeah, let's continue. Now, if you have understood how we are proceeding, let's try doing this question. Sin A plus cosec A whole square plus cos A plus sec A whole square is equals to 7 plus tan square A plus cot square A. Let's try proving it. Yeah. So after seeing this question, one thing is coming in our mind. Are you thinking about the same? First, you let me know. What are you thinking?
A plus B whole square.
A plus B whole square. Just after looking at the question, this is what is coming in mind, that let's expand the left hand side and then we will be thinking what can be done. So let's do it quick. Sin square. Okay. Plus 2ab, 2ab plus cos square. Similarly, now cos square, this is cosec square. Cos square plus 2 cos A into sin A plus sec square A. Now what? We did the quick expansion we have done. Now what to do? Anyone having any idea what to do now?
Can we do sin a square plus cos a square is equals to 1
Exactly, we can do so.
and
I'll
cosec
explain.
square plus sec square is equals to 1?
Yes,
No. But cosec plus sec square is,
not 1.
yeah,
Okay, that is not 1. Okay, cosec and cot is 1. Sec and tan is 1. Sine and cos is 1. So sine square and cos square, we can take it together to the two underlined part, not this one. And then we can say it's nothing but just 1. Perfect, Aisha. Then what? Can you see this? Can you see this? This is sec.
yes. You can take the common.
No, nothing is common. Check it carefully. Sine, cosec. Cos, sec. We can take two. We can take out common, but after that, I am asking you something. Sine A into cosec is what?
Um,
Huh? Sine A into cosec is sine A into cosec is cosec means
cosec is 1 by sin a.
then the result will be
The sin square is,
cosec means 1 by sine A. You said, Aisha. Result will be
the sin square into 1 by sin
sine
a.
we can cancel and the result is 1. Yes or no?
Yeah,
If we are having 3 into 1 by 3, the result is 1, right?
yeah.
Yes. Yes.
Okay, so here you must notice that sine A cosec A, it's 1. 2 with 1 we are having, 2 will be the like result from here, and from there also we'll be having only 2. And in between whatever is there, that will remain as it is, that is cosec square plus, okay, cos we have already used. Let me write this 2 over here. Yeah. 1 plus 2 is what?
5.
5. Okay. And then we are having plus cosec square A plus sec square A. Right?
Yes.
We have to prove tan and cot. From cosec and sec, is it possible to make tan and cot? Is it possible to make tan
Yes.
and cot? How? By using the
Um,
identity. What can be written for this cosec A? There was identity. Number 1, sine square plus cos square is equals to 1. A or theta, whatever. Number 2, sec square minus tan square is equals to 1. Number 3, cosec square minus cot square is equals to 1. So cosec square can be written as
4 square.
1 plus cot square, yes or no?
Yes.
And sec square can be written as
1 plus tan square.
1 plus tan square. Now 5 plus 1 is
7.
7. And cot square, tan square, we will be writing as it is. And then again we will get back to right hand side and we will check, are we done or still we need to do something? Are we done? Are we done?
Yes.
So we don't know what to do over here. We don't know. See, you are doing it. I'm not doing it. You are doing it. Okay? Randomly, we are just trying to figure it out. What can be done? At first, it looked like the formula a plus b whole square. We did that. After that, sin square, cos square, the identity we found here. We applied the like one we have written for that. Then sin a, cos a, we must understand that is nothing but 1. So we have written 2 over here, 2 over there, just 2. After that, cosec and sec as it is, it left out. Now we will go and see the RHS and we will keep on looking at the RHS and we will be thinking tan is there, cot is there, tan is there, cot is there, how to make tan and cot, and hence we figured it out and we are done. Getting it? Okay, let's continue. Next one, let's take it. Let's finish it today. Cosec A minus sin sec A minus cos A is equals to 1 by tan A plus cot A. What to do over here? It looks like simplification can be done on the left side. So let's try working on left side. Let's try it. Okay. Cosec is there, sin is there, sec is there, cos is there. What can be done? Can we convert cosec in terms of sine? Can we? Can we? And this sec in terms of cos? Can we? We don't know whether we are going to get the right hand side or not. Whatever we can see, we are trying to figure it out. Cosec can be written as 1 by sine, sec can be written as 1 by cos, and then we can see here LCM we can take out. Yes or no? Yes or no? Can we take out LCM in the first bracket and we can work on it separately, and then LCM in the second bracket and we can work on it separately? Can we?
Yes. Yes.
What will be the LCM in the first bracket? Who will say?
Sin.
Nine. And what are we going to have in the numerators part?
1 minus sin square.
Exact. And here 1 minus cos square by cos A. Now still it looks like if we can go ahead one more step. What can be written over here? Who will say?
1 minus sin square can be written as cos square A.
Now what?
You can simplify then we'll get the answer as cos A by sin.
By
No, not
Aisha?
by sin. Cos A into sin.
Hmm. Let's try solving the other part also. 1 by tan A plus cot A. Maybe we will be getting this result and then we will say that we are done. Sin by cos. Cos by sin. Then what will be the LCM for the denominators part?
C to sin
Cos A sin.
Cos is sin A. And what will be there in the numerator of it?
sin square A plus cos square A.
Perfect. That is just one, right?
Yes, ma'am.
So 1 by sin A cos A. Okay, if you will try simplifying it the way we do always, you must convert it in fraction by fraction. That is 1 by 1 is there. 1 by 1 is there and then the denominator is in fraction, numerator denominator. Okay, the outer part will multiply together and will sit in the numerators part. And the inner term will multiply together and will sit in the denominator. So basically we are, otherwise the way Aisha you do that when we are having one by when we are having 1 by sin A cos A, that way also we can do 1 divided with 1 by sin A cos A. That means
Yes.
1 multiplied with
1 multiplied by.
okay. So this is what we are also getting sin A cos A from here. Hence we are done. Hence we are done. Right? Any
Yes.
confusion? It requires huge practice. Okay, you have to practice different types of questions by yourself. Now here we are having the last question from this chapter is 1 plus tan square A by 1 plus cot square A. Here we are having is equals to 1 minus tan A, 1 minus cot A is equals to tan square A. All we have to prove. The first part is equals to the second part is equals to the third part. We have to prove it. Let's try working on the first part at least for now. Okay, 1 plus tan square by 1 plus cot square. So 1 plus sin square by cos square. Quick we'll be doing because now we are pro at it. Okay, we have done so many questions and we have become pro now. Now quickly we will be doing it and we understand cos square is the LCM. A will be there, of course. If I am not writing A, you should write. You should not avoid writing A since I am doing it quickly. Here we'll be having cos square A plus sin square A, which is nothing but just 1. Here we'll be having sin square A plus cos square A, which is nothing but just 1. Okay, and this complete is 1, this complete is 1. So we will be having, it seems like we are done with proving the last part. That is 1 by cos square A and here 1 by sin square A. That means nothing but just tan square A. Yes or no? So we have proved the first part and the last part are same. But what about the second part? Now we will take the second part and we will try working on it. Maybe we will be getting, after solving, simplifying, maybe we again will be getting the tan square A and then we can say that all are just equal with each other. Okay, so 1 minus tan A by 1 minus cot A whole square is there. Let's do it quick. 1 minus tan A, the middle part I have taken, okay? 1 minus cot A and that's complete square is there. Okay, is equals to 1 minus sin by cos. over 1 minus cos by sine, but we will not forget that there is a complete square. Okay, now we'll be having cos A minus sine A by cos A, and we will be having again sine A minus cos A by sine A, and we know already how to make A minus B to B minus A, how to make this to this we know already, okay, by taking a negative sign common. But let's simplify it at first. So this sine A will go in the numerator, this sine A will get multiplied with this term cos A minus sine A, and this cos A will get multiplied, the inner term will multiply together. Are you getting any confusion? Anyone having any confusion so far? If I'm doing it quickly, square is still there. Anyone having any confusion so far?
Oh, ma'am.
Okay. See, this particular simplification and all, we are doing it from the very beginning. Okay. Now we can take out minus common, maybe from the denominator's bracket or maybe from the numerator.